Hello, my name is Nick DePietro and I'm here to talk to you about air resistance. Air resistance is a force acting opposite to the relative motion of an object. So if an object is moving to the left, then air resistance will move to the right and vice versa. However much air resistance an object gets depends on its cross-sectional area and the speed of an object. For the first demonstration, we will focus on speed by tossing this paper airplane twice at two different speeds. First, I will throw the paper airplane slow. And now I will throw the paper airplane again, but even faster. Notice the only thing that changed in that experiment was the speed. The first time the plane flew, it experienced less air resistance because it moved slow. The second time the plane moved, it experienced more air resistance because it moved that much faster. For demo 1, I made two force diagrams to show the forces acting on the plane after it's released with more and less applied force. As I explained earlier, the slower an object moves, the less air resistance it will encounter. That being said, the object of interest, the plane, will have a shorter line of air resistance abbreviated as AR, thus pointing the net force arrow to the left. When the plane is thrown faster, we will draw a longer line of air resistance because it is more significant, thus pointing the net force arrow to the left again, but larger to match that of the air resistance. Now let's focus on the cross-sectional area of an object and see how that affects its air resistance. I have here another paper airplane I've constructed, a little larger scale, larger wings, and overall a larger frontal area than the first plane we used in demo 1. I will now throw the two planes so they have the same initial speed. Both planes had the same speed, but the one with the bigger cross-sectional area had a larger force of air resistance acting on it. For demo 2, I made two force diagrams again to demonstrate the plane flying with a greater cross-sectional area and a smaller cross-sectional area, thrown with the same initial speed. The plane with the greater cross-sectional area will get a longer line of air resistance, thus pointing the net force arrow to the left. The plane with the smaller cross-sectional area will have a smaller line of air resistance, thus pointing the net force arrow to the left again, but only smaller to match that of the air resistance. And some other things to remember, do not get weight and area mixed up. Just because something may be taller in height does not mean it weighs more, and the weight should not be in the analysis in the first place. Time is important when dealing with force diagrams, especially with air resistance. An object's air resistance after its initial release can be very different compared to the air resistance over time. And cross-sectional area and frontal area are the same thing. Thank you.